Hello guys, today we are to look at rational and irrational numbers. Rational and irrational numbers. I'm going to take this topic in a very simplest way for you to understand it. When we talk about a rational number, we are saying a rational number is anything that can be written as a fraction. So if I have my A and B, then we can see that this is a rational number where B is not equals to 0. Then we can talk about a rational number. But in most cases, many people confuse themselves with rational numbers and irrational numbers. I would like to start with irrational numbers. Irrational numbers. Now, how do we know that a number is an irrational number? A number is said to be an irrational number first if that number is a pi. If you see pi is an irrational number. And then the second thing that we can just look at to see that a number is an irrational number is that if the number is an imperfect square. Imperfect square. I'll give you an example to this effect. And then the third one is that if the number is no having pattern. So you see no pattern. Okay? No pattern. So these are the three aspects or things that you need to look at. Immediately you see pi is an irrational number. And then when you see that the number is an imperfect square, so with the pi, I think I have to also add the e. When you see e or pi, then we say it is irrational number. Then when you see imperfect square, it is also an irrational number. For example, if I give you square root of 1, you see we are getting 1. So it means that 1 is a perfect square. If I give you square root of 4, you get 2. So square root of 4 is giving you 2. And that is what? A perfect square. But if I give you a square root of 5, over here, it will give us a decimal number. You see, 5 is not a perfect square. So we call 5 as an imperfect square. So any number, when you find the square root of it and you're getting a decimal number, then it means that that number is what? An irrational number. And that's what we call imperfect squares. And then the last one is that it has no pattern. For example, if I have something like 2.348624814, this number keeps on repeating. But if you look at the numbers, it is not having any pattern. Nothing is what? Repeating here. Don't let this dot here to confuse you that because it continues, so it is repeating. No. We look at the pattern. The number has no pattern. So it tells you that this number is what? An irrational number. So let me take it again. First, look at the number. If the number is pi or e, it is irrational number. If the number is an imperfect square, when you find the square root of that number and you're not getting an integer, then it means that that number is an irrational number. Then lastly, the number is having a repeating dot at the end, but the numbers has no pattern. So these are called irrational numbers. So these are the qualities or the features you have to look at. If you see any three of them, then it means that the number is an irrational number. So now, if I write a number like square root of 9, because square root of 9 will give us 3, then it means square root of 9 is a rational number. If I write 2 over 3, it is a fraction, irrational number. If I give you 0.4, it's a decimal number. It is a rational number. So rational number 0.4, 2 over 3 is rational number, and then square root of 9 is also a rational number. And all integers, both positive, negative, or 0, are all what? Rational numbers. I hope we are there together. So now, let's pick some examples of rational numbers. 1 out of 2 is a rational number. We have 3 out of 4. We have negative 5 is a rational number. 0.25 is a rational number. We have 7 is a rational number. Negative 2 over 3 is a rational number. 4.5 is a rational number. 0 is a rational number. If I write 9 out of 1 is a rational number, then 0.125 is a rational number. All these numbers are rational numbers. So we can see if I write 0.343434, so we can see that there is a repeating. 34 is repeating. So it makes this one a rational number. So in other words, repeating and terminating decimals are rational numbers. So these are examples of rational numbers. Then on the other side, the examples of irrational numbers is in square root of 2. Because square root of 2 will give you a decimal number. So it means this number is not a rational, but rather irrational. Square root of 3, irrational. Pi is irrational. Square root of 7, irrational. Then pi times this is irrational. Okay? 2 plus square root of 5 is what? Irrational. Because the square root of 5 here will give you a decimal number. So anytime you see the square root of any number that gives you a decimal number, then it means that number is irrational. And then they can also give you an example like this one, like 0.34, this one 2, 3, 4, 3, 1, 4, and it is repeating. Because this one has no pattern, then it means this is what? Irrational number. Thank you very much. I hope this lesson has been a very wonderful. Thank you very much. Bye-bye. See you next time.